Observatory. This is the oldest public observatory in the United States, and we are going to go ahead and take a tour of it. My name is Natalia Tooley. I'm an educator here at the Cincinnati Observatory. So we're going to start off with the older of our two telescopes today, which is the oldest telescope in the United States. So let's get started. So what makes observatories different from planetariums is that observatories have telescopes. Now here at the Cincinnati Observatory, we have two different telescopes, and so this is the older of our two telescopes. We like to call this telescope the Mitchell telescope, and this is 175, about to be 176 years old. So we actually count how old a telescope is by the first time it was looked through as opposed to when it was first made. So this was first looked through in 1845, so it's 175 years old. And so even though this telescope looks really big and heavy, it's actually pretty easy to move around. All you have to do is push it with one finger and it moves. And so we move this telescope around pretty much all by hand and also by rope as well. And we have to move it pretty carefully because this telescope moves around so easily, and we want to make sure to keep it in the most pristine condition possible. So say if we wanted to look at this side of the sky tonight, we would keep this telescope on this side of the base and just kind of move it around like this. However, if we wanted to look at this side of the sky, we would have to flip the telescope over. So we're going to go ahead and do that right now. So I have to put the telescope so that it's parallel with this piece right here. And then can I have a handy dandy assistant to hold on to this rope? So you're just going to hold on to this. Yep, just like that. And as I flip it, you're going to walk with it just to make sure it doesn't tip that way. So I pull on this rope over here. And this is how we move the telescope around the room. Just like that. Once we get the telescope in the right spot, wherever it is that we want to see, then the next step is going to be to open up the roof, because unfortunately our telescopes don't have X-ray vision, so we need to make sure that we have the clearest view of the night sky. So we open up the roof by using these two ropes right here. We pull this one to unlock it, and then pull this one to open it. You may notice that even though the roof opens up, it doesn't open up that wide. So then the next thing we need to figure out is how are we going to move that opening so that we're able to see any portion of the night sky that we would like to. And so what we do is we use this wheel over here, and when you spin this wheel, it moves through. How night viewing works. We have to move the roof and move the telescope to wherever it is that we want to look at things, and the roof can move around 360 degrees wherever it is that you would like to look. We also have this set of stairs right here, which is on wheels, because a lot of times what happens is, say if you want to look at something that's directly above you, having the telescope right here is perfectly fine. But if you want to look at something that's low on the horizon, pretty soon the telescope is going to be up too high for you to be able to see through it, and that's why we need these stairs to be able to move anywhere around the room so that we can see whatever it is that we want to look at. A lot of times, when you're looking through a telescope, you are looking at an image so zoomed in that after a while that image starts to move out of view, because it looks like throughout the night that stars move throughout the night sky. Now, is it really the stars moving? No, it's actually the Earth that is moving. But because the Earth moves, it makes it look like everything in the sky is moving. So your telescope has to be able to move along with it. And so that's why we have this right over here. Here is the tracker system, the original tracker tracker system that was on this telescope. Basically, this works almost like a grandfather clock. These weights would drop down and gears would pull it back up, and this would slowly move the telescope at the same rate that the stars move, so you're not having to constantly adjust it. Now, the old tracker on this telescope isn't really in working condition anymore, so now instead, we just flip a little light switch back here. And even though you can't actually see the telescope as it moves because it's moving so slowly, if you turn that tracker on and left this room for an hour and came back, you would see that this telescope is in a completely different spot inside of the room, and it moved all on its own because of the tracker. Now, a lot of people like to ask us, well, how far away can you see from Earth with this telescope? And that all depends on what eyepiece you put inside of the telescope. So our eyepieces, they almost look like lenses that you would put on the end of a camera, and you put them over here inside of the bottom part of the telescope where you look through. So you would take out this little metal piece right here and then put this in its place and look through like that. And depending on what eyepiece you use, that basically decides how zoomed in you're going to be seeing. So say if you want to look at something that's really close to us, like the moon for example, you would use one of these with a piece of glass that is really far across, because then it doesn't zoom in as much. But if you want to look at something really far away, like say a star cluster in another part of our galaxy or a nebula, then you're going to want to use something like this with a piece of glass that's smaller, going from this side to this side, so that you can see things more zoomed in. So we are going to go ahead and move on to go see the younger of our two telescopes, which is also the larger of our two telescopes. The Clark telescope is actually up quite a large flight of stairs to go get up to the dome room. So we're going to go upstairs to go check it out. Telescope, and even though this is the younger of our two telescopes, this telescope is 116, about to be 117 years old. So this telescope was first looked through in 1904, and even though, again, just like the other telescope, it looks really big and heavy, you can take one hand and push it pretty easily. But then, unlike the other telescope that we just went to go see, you get to a point where you can't reach it anymore. And once you get to that point, instead of using ropes, we use wheels. And so we have this top wheel right here, and that moves the telescope going up and down, just like this. And then we have a bottom wheel that moves the telescope side to side. And this is how we move the telescope around the room. And so this dome room is also very similar to the dome room that we just saw, that in order for us to be able to see the night sky, we want to open up the roof. And so we have our ropes over here. And that is as wide as the roof opens. And then we go over to our wheel over here, and this is how we move the roof. Now, something that you would notice when you first stepped into this room is that it's usually about the same temperature in here as it is outside. So that means when it's 20 degrees outside, in the middle of winter, it's 20 degrees in here, and during the summer when it's 90 degrees outside, it's 90 degrees in here. And the reason that we do that is because we want to make sure that we protect the telescope from condensation. If you've ever had maybe a cold Coke on a hot summer day, you may notice that little water droplets condense on the outside of the Coke can. Well, the same thing can happen to our telescope, the outside of our telescope, if we have a really big temperature difference between outside and inside the dome room. And so we make sure to do everything we can to keep the telescopes in the best condition possible, and also to make sure that we don't get any weird wavy air that sometimes you'll get with drastic temperature differences in front of our telescope, because even small things like that, even a change in humidity, even allergens, all can be things that can obstruct your view when you're looking through a telescope. So what we're going to do now, since it's daytime and we won't actually be able to see any of the stars or star clusters or anything like that because it's too bright outside right now, instead what we're going to do is I'm going to flip the telescope upside down so you guys can take a look at what the inside of a telescope looks like. So we always keep a lens cover on the top of the telescope because the way these telescopes work is that they have large pieces of glass at the top that's basically almost like a magnifying lens. And so we need to be very, very careful with this piece of glass because it could get scratched really, really easily. And so we want to make sure that we're protecting it from getting scratched and also protecting it from getting too dirty. So whenever we're not using it, we keep it covered. Here is what the inside of the telescope looks like. Something that you may notice is that the inside looks even bigger than the outside, and that's because when you look through this telescope the correct way, it's meant to magnify. So when you look through it the opposite way, it's almost like looking through a pair of binoculars backwards. It makes everything look further away, and it almost makes it look like the telescope is going through the roof if you're just looking at the inside. But you may notice that this technology is actually really, really simple. And so telescopes like the two that I've shown you today, they are called refracting telescopes. And that means that they have glass inside of them. And so basically, there's two pieces of glass inside of this telescope and then one small mirror at the end to bounce the image into your eye. Now, this is not the only kind of telescope. A lot of telescopes now, instead of using pieces of glass, use mirrors, because when you use a mirror for a telescope, that means you can make the telescope as large as you want to, as big as you can make a mirror. That's how big you can make a working telescope. But this is kind of the old-fashioned way that people would make telescopes. And so just like the other telescope that we looked at, this telescope has a way to track and move along with the stars as well. But instead of that tracker being on the outside of the telescope, it's on the inside of the telescope. So you have this little door right here. If you look inside, there's a 400-pound weight inside of this telescope. And so this weight also works kind of like a clock drive. And so basically what you do is you crank this, and that pulls the weight up. And then that starts spinning a little gold piece up here called a governor. And the governor starts spinning these little Reese cup shaped gears over here, which start spinning the gears out here, which slowly moves the telescope at the same rate that the stars move. So when astronomers used to use this observatory for research in the early 1900s, a lot of times they would hire teenagers to come here and help them re-crank the tracker and help them move the telescope and move the stairs around the room. So these teenagers would spend all day at school, rush and do their homework, and then come here to the observatory and stay up all night helping the astronomer re-crank the tracker and do all the other things that needed to be done. And for staying up all night long, these teenagers made 25 cents a night, which doesn't sound like good money, and even back then, it wasn't. But they got to look through this telescope and see things that no one else they knew got to see, and that's pretty cool. And then if you want to, there's a little small museum area down there if you wanted to go and take